Now, dear students, it is important to note that the previous discussion which we have done, definitely we have done, I told you repeatedly that we have done it in case of the two particle system, right? It will be asked for the two particle system because in our syllabus it is for the two particle system, the derivation, but it can be extended up to the n number of the particles. That can be done. So I have extended to n number of particles, then that expression will be, I have written it like this: r vector cm means it is the position vector for the center of mass of the system is equal to m1 r1 vector plus f2 r2 vector and so on, like this. Now, you know, if r1 vector is resolved into x1, y1, z1, r2 vector is resolved into x2, y2, z2, and similarly rn vector and so on will be resolved into xn, yn and zn respectively, like this. Then what will happen? We shall write it here. Obviously, our cm vector should also be resolved, that is xcm, ycm and zcm. Just see. Then what we shall have? We shall have here, from our concept of vectors, rcm vector will be xcm I cap plus ycm j cap plus zcm k cap. Very clear. That should be equal to, on right hand side, I will write m1 x1 I plus y1 j plus z1 k plus m2 x2 I plus y2 j plus z2 k. Okay, it will go like this, and plus dot 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 mn xn I plus yn j plus zn k, and divided by, as usual, m1 plus m2 as so on up to n. Now I write here equating the coefficients of I cap, j cap and k cap from both sides. xcm is equal to m1 x1 plus m2 x2 and so on up to mn xn by m1 plus m2 dot 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 mn. Look, what is ycm? That is m1 y1, m2 y2 and so on, mn yn by m1 plus m2 dot 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 mn. And the third one, zcm, is equal to m1 z1, m2 z2 and so on, mn zn by m1 plus m2 dot 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 mn. Look, very important expressions I am getting, because I tell you, this expression, that is the vectorial expression, these expressions are the scalar expressions, and these expressions are very helpful in doing the numericals. As I told you, it has been extended up to n number of the particles, but you can do it for any number of particles. अगर मान लो किसी सिस्टम में 4 पार्टिकल्स के लिए, तो इसको 4 पार्टिकल्स के लिए यूज करो. अगर इसको 5 पार्टिकल्स है, 5 पार्टिकल्स के लिए यूज करो. Whatever is the number of particles, for that you can use this formula. Very useful formula it is. Because this scalar formula, we have found out the coordinates, x coordinate, y coordinate and z coordinates of the center of mass. इसके द्वारा ही तुम न्यूमेरिकल्स सॉल्व कर सकते हो. Any numericals can be solved with the help of this equation only. That means you can say this formula only. Without this formula you cannot solve a question. Right. Suppose, for example, I just tell you one question is there. I mentioned one question just to understand the concept of it. I write here a problem. Let us discuss a problem. Problem is, find the center of mass of three particles at the center of an equilateral triangle. Suppose a equilateral triangle दिया हुआ है. Try to follow me. Suppose an equilateral triangle is given. Okay, and its each side is 0.5 meter long. Followed? It is said here that 100 gram, 150 and 200 gram. 100 gram, here is 150 and here is 200 gram are placed. Just try to understand this question. This is one problem I am discussing. In this problem, it is said that there is an equilateral triangle, three masses, 100 gram, 150 gram, 200 gram are placed at the three vertices of the equilateral triangle. I think it is very clear. Each side is 0.5 meter long. Then you have to find out the center of mass of this three particle system. Right. So since this as a three particle system, इसका तुम्हें center of mass निकालना है. कैसे निकालेंगे हम? सेंटर ऑफ मास निकालने के लिए मैं यहां से अब इस फॉर्मूला को यूज करूंगा. लेकिन कैसे यूज करूंगा? इसमें यूज करूंगा m1x1 प्लस m2x2 प्लस m3x3. बस वहीं तक जाकर टर्मिनेट कर देंगे. तो कैसे करेंगे? सबसे पहले फॉर दैट आई हैव टू, सिंस आई हैव टू फाइंड आउट द कोऑर्डिनेट्स ऑफ दिस सेंटर ऑफ मास, देन we should have an axis system. Very simple. इसको तुम x axis बना दो, इसको तुम y axis बना दो. ये axis बनाना हमारे ऊपर. इसका कोऑर्डिनेट हो जाएगा 0 0. इट्स अ प्लेन. ठीक है, ये 0 0 प्लेन हो गया. तो अब मैं क्या करूंगा? मैं अगर इसको मैं m1 मानता हूं, इसको मैं m2 कंसीडर करता हूं, इसको मैं m3 कंसीडर करता हूं. यूज दिस फॉर्मूला. व्हाट इज x? x सेंटर ऑफ मास xcm निकालो. कितना होगा? सबसे पहले मैं लिखूंगा फर्स्ट वन m1. ये क्या होगा? ये डिस्टेंस कितने के बराबर होगा? ये डिस्टेंस 0.25 होगा. देखो 100 इंटू 0.25 प्लस 100 into 0.25 m1 x1 then plus this is 150 into 0 plus here 200 into how much? 0.5 by 100 plus 150 plus 200. How much I am getting? I am getting 25 plus 0 plus 100 divided by, it is 450. Just check it. It is 25 plus 0 plus this. Yes. Then how much you are getting? You are getting here 125 by 450. How much we are getting? It is 20. I can say 25. 25. It is 5. And I think 25 5 by 18 is one coordinate. You can understand. Second one, YCM कितना होगा? First mass is 100 into this distance. You see, you have to take this distance. how much will be this distance? It will be, you can say, ये वाला वैल्यू तुम निकाल सकते हो. मान लो इसका वैल्यू को अगर मैं स्मॉल y कंसीडर करूं तो स्मॉल y का वैल्यू तुम निकाल लोगे 100 इंटू स्मॉल y प्लस 150 इंटू 0 प्लस 200 into also 0 by 450. Look at this. I take it in this way. See these two, and y. How to find out y? Y is equal to how much? Y is equal to root 0.5 whole square minus 0.25 whole square. I think you can get it using Pythagoras theorem. Y का value निकल जाएगा. This you put it here and you get the answer. Just see how I have done it simply by using this formula. It's a very simple formula to understand. So I hope, dear student, I think you all have understood these things, right? So we stop here only today. Up to this mark we are keeping it. In the next class we shall again proceed. Okay? Up to this mark you first see, it's a bit difficult chapter. You have to understand it properly. First you grasp this whole thing. In the next class again we shall continue it. Okay? Thank you.